Hello, Richard here. Welcome to part 4 of the Build Your Own CSGO C4 prop series. And in this one, we're going to be talking about software. Now, when I say software, we've got a few things we need to talk about in this one. We need to talk about the sound files. You need to get the sounds into the Arduino, or rather into the MP3 player. MP3 player, remember that? Yeah. We need to get the sounds into the MP3 player, so we're going to talk about that. We need to look at the actual Arduino source code, so we're going to look at that. And then thirdly, there's a little Windows Desktop client application that goes with this. It lets you sort of manage the CSGO prop, things like set the time and the backlight display brightness and things like that. So we got 3 things to go over. And the first thing we're going to do is talk about how on earth you get the sounds into the device, and why do we refer to the sound playback device as an MP3 player. Yeah, we'll talk about that in a moment. Okay, so the sounds. Now, as always, there's a web page that supports this video. So if you go over to blog.radboogie.com, you can see we've got a web page set up for this, and I'll put a link in the description as well. And this page basically covers all the things we're going to talk about here. We talk about how to get the sounds into the device. We talk about how to map the sounds here. We'll come back to this in a minute, don't worry. How to convert them into the correct format. And then we've got the source code. There's a big listing here of all the source code for the Arduino. And then we've got a section about the CSGO C4 configurator. And finally, the downloads and all that sort of stuff. And we'll come back to this as we go through the video. Okay, the first thing we need to do is talk about the sounds and how you get the sounds into the device so that you can play them back. Things like explosions and terrorist win and all that sort of stuff. So the easiest way to get hold of the sounds, there's a few ways you can do this, but the easiest way is there's a YouTube video by a guy called Isan Aditama, and I hope I got your name right there, my friend. This awesome guy has put all the CSGO sounds into one big video on YouTube, and I'll put a link to that in the description. And what I suggest you do is go over to this video. It's literally just all of the sounds with their names if you play it. Brings back memories, doesn't it? So yeah, go here, and with this video, what you want to do is use your favorite utility. There are online utilities where you can basically download an MP3 file from a YouTube video. Now, I won't post a link to any of those because they come and go. So you can find one of those yourself. Just Google search for sort of YouTube to MP3. And ideally, you just basically get the MP3 file from this video, and then we can move on to the next step. If in the future this video isn't there for any reason, let's say the guy takes it down or whatever, there are other options. And what you can do is you could basically find another video with all the sounds that would work. Or if you can't get a video with all the sounds for CSGO in it, just basically fire up the game, play the game, and then use something like OBS screen capture software to record the gameplay. And then you can extract the MP3 from the OBS video. Now, OBS will record the video as an MP4 file. And if you want to extract the MP3 from the MP4, in other words, the audio from the video, then you can use VLC Player to do that. And I'm not going to show you how to do that because there's loads of videos showing how to use VLC to pull MP3s out of MP4s. But at the end of the day, what you need to do is end up with an MP3 file of all the CSGO sounds. Okay, next, you need to chop the MP3 file into individual WAV files for each of the sounds in the game. And if you go over to the website again, and we scroll down the page a bit, you can see there's a little table I've put here, which is a reference for you. So you can look at this table, and this tells you all the sounds I use in the C4 prop, what I call them in the code. So this column is what I call them in the actual source code. Oops, this column here on the left. And the game sound name column, this is what they were called in that video, and I presume this is the actual in-game variable names for the sounds. And on the right is what you need to name them as. So let's just rewind a little bit, and what I'll do, I'll show you how you can extract the WAV files from the MP3. So to do that, what you want to do is fire up Audacity. And Audacity is a free sound editing program, and it's really awesome for working with MP3s and WAV files and chopping things up and all that sort of stuff. So what you want to do is go into Audacity and then open the MP3 file that you downloaded. And I've got a sort of a cut down version here, so we're not working with the whole thing. And if we play this, you can hear we've got the game sounds in the MP3 file. So what you need to do is identify each sound that you want, and then basically cut it out. Now, there's a few things we need to do before we do this. What we're going to do is we're going to extract the MP3 files into WAV files, and then we need to convert the WAV files into .ad4 files. And yeah, this is why we refer to the MP3 player like we do, because it's not really an MP3 player. It's a .ad4 player. And like, yeah, I've never heard of AD4 files either. So there's a lot of steps in this. Rather than just being able to like pull out MP3 files and put them on an MP3 player, we have to sort of go around the houses to get them in the suitable format. So the first thing we need to do is we need to convert this to mono. This is coming as stereo. So you can do that if you go to tracks and mix stereo down to mono. That's the first thing to do. So the next thing we need to do is set the format to 16-bit PCM. So if we click on where it says CSGO here, that's just the name that I happen to have for the file. And then we go down to format, make sure it's set to 16-bit PCM. And now the other thing you need to do is make sure that the project rate is set to 32 kilohertz or 32,000 hertz. So we'll do that. So we've got 16-bit PCM mono, 32,000 hertz, and that's what we need to be able to convert to AD4. So now what we'll do is we'll just pick a sound, and let's select that one and play that. Okay, we want to extract that. So what we'll do is we'll go File, Export, Selected Audio. And we need to give this a file name. So what we'll do is we'll refer back to the web page, and that one I think was the about to blow sound, NVG on. And here it says it needs to be 003.wav. So we'll use that for our file name. We'll save that as 003.wav and click on save. So basically you need to do that for all of the files. So extract all of the sounds, save them to WAV files, and give them names such as this. And then once you've done that, you can then move on to the next stage, which is to convert them to an AD4 format. Now, if you scroll down on the web page a bit, you can see we've got a section on converting to AD4. Basically, what you want to do is download the AD4 converter, which is, there's a link here, so you can download it from the website, or you can just go elsewhere. You can download it anywhere else on the web. I'll just put that there for your convenience. So the easiest thing to do is to put the AD4 converter in the same folder where you put the sound files, like so. So here we've just got the one file, 003.wav. We've got our original CSGO MP3 file, and we've got the AD4 converter. Then you want to fire up a command prompt and navigate to the same folder where all the files are. So if you type dir, you can see we've got all those files. And then if you look on the website, we've got the command you need to use here. So what we do is we type that in. So type AD4 converter, spell it right, will give you a better fighting chance of success. So AD4 converter .exe minus capital E4, and then the name of the WAV file. We've got 003.wav. Press enter, and then if you do dir again, you can see that we've got 003.ad4. So basically repeat that, just repeat that for every WAV file until you've got all of the AD4 files. So an AD4 file for each of these. When you've got that, pop them onto the SD card that goes into the MP3 player, and that's it. That's the sounds done, and everything should be fine. Now, it's worth bearing in mind as well that as you're doing this, you don't have to use the sound files that I've shown you here. These are just the sounds that I used when I made the device. You can pick any sounds from the game that you want. So if you wanted a different faction for the defusing sounds and things like that, then go ahead and just use whatever you want. Or you can record your own voice, or you can put whatever you want on there. But this gives you an idea of how I did it. So feel free to copy that or do your own thing as you see fit. Okay, right. Next, the source code. All right. I know it's been a long time coming. The source code. The source code's on the website. So there's a full listing here, so you can browse through the code here. And as I said, there's a download as well at the bottom of the web page where you can download all of that as you need. But what we'll do, we're just going to have a quick sort of walk through the code. Now, with the source code, you could just download this, upload it to the Arduino, and you're done. That's it. Never have to look back, and it will just work. As long as you've wired everything up and you've used the same hardware that I have, it should all work. But I sense that some of you may wish to modify this and customize it. So in which case, we'll have a little bit of a walk through the code. I'll tell you a little bit how it's structured, and then we can go from there. So I'm going to use Visual Studio Pro for the source code. This is what I use to develop for the Arduino. Now, of course, you can use the Arduino IDE. Nothing wrong with that at all. I've done quite a lot of work in the past using the Arduino IDE, and it works absolutely fine. But what I find is I use Visual Studio as my daily driver. That's my daily software development tool. And I'm just so used to it after like 20 years of using that if I try and use the Arduino IDE, I just press all the wrong keyboard shortcuts and delete more code than I write. So I'm used to Visual Studio, so that's what I use. And that's what I'll be using today. But you can just as easily use this. Use whatever you're comfortable with. One good thing with Visual Studio is you may see here on this menu, I've got a plugin which is called vMicro. And this is a plugin for Visual Studio that makes working with Arduinos really easy. So you can see I've got all the Arduino sort of menus, COM ports, and all that sort of stuff in Visual Studio. So I can work in Visual Studio, I can write my code in here, and I can upload it to the Arduino from here and debug it and use a serial monitor, and I can write unit tests, and I can do all kinds of cool things doing this. Now, you don't have to do that, but it's a handy little tool if you do want to. It is a paid plugin. There's a web page for visualmicro.com if you're interested in that. I don't get any kickback from this. I have no affiliation with them. It's just another neat plugin. As I say, you do have to buy this. I think you get a free trial, and then it's a paid plugin. But if you're doing a lot of Arduino development and you want more advanced tools, then yeah, definitely worth checking that out. Back to Visual Studio. Like I said, we'll have a quick walk through the source code, and I'll tell you a little bit about it, which hopefully will help you if you want to modify things. Starting off at the top, you can see we've got some includes, and it's not my intention really to give you like a tutorial on how to program an Arduino or write code in C++. So we're not going to sort of dig too deeply into that side of it. What we see here with the includes is these are basically external libraries or external chunks of code that make the hardware work. So if you use a PC, you're probably familiar with device drivers. You've used a graphics card, which has device drivers, and the operating system talks to the device driver, which is a piece of software that then knows how to talk to the hardware, which is your graphics card. So with an Arduino, if you plug in like a real-time clock, you don't want to have to then get the technical data sheets for the real-time clock and then work out all the timings and the I/O lines and write all the low-level code to make that work. No, all you want to do is download a library of code. Someone else has written that for you, and you download a real-time clock library, and then you just basically call the functions in that, and it then knows how to talk to the hardware. So that's all we're doing here. All these includes are basically little links to code written by other people that makes the hardware easier to talk to. Now, on the web page, if you scroll down past the source code, there's a little table I've put in here, again, for your convenience. And this basically lists the includes, the external libraries that I used in making this or in writing this code. And we've got the library name, what it talks to, so you know what its function is, the author, which is handy if you're looking in the library manager. Let's flip over to the Arduino IDE. In the Arduino IDE, if you want to install more libraries, you'd go Tools, Manage Libraries. And in the library manager, you'll see a list of all the libraries. And if you want a library, like say keypad, let's try that. You type that in, and this narrows it down to libraries matching the word keypad. And one of the things you'll see is the author is listed alongside the libraries. So I've put the author alongside each one, so it helps you to know you're on the same one as I was. Also the version, these are the versions that I was using. You don't have to use exactly the same versions, but this gives you an idea that, you know, if you do experience any problems, then there may be a compatibility issue and you can make sure you're on the same version. All right, so walking on with the code, the beginning here is all initialization. And what we mean by that is that all the different devices, we kind of have to initialize the hardware modules, things like the liquid crystal display and the keypad and things like that. We have to sort of define which pins that they communicate on. So that's what we're doing here. So you can see that, for example, the liquid crystal, we're initializing that with the actual I/O pins that it's going to be using. So RS is 4, EN is 5, D4 is 6, and so on. If you've wired yours the same way I did, then there's nothing to change here. If for any reason you're using a different wiring configuration, this is where you could change that. Here we got some values to do with the EEPROM day bright address, EEPROM night bright address. With the prop, if we power it up, you can see we've got the LCD screen, and this is quite bright. Because this is designed to be a bedside clock as well, what you don't probably want is like to have this being really bright in your face at 3 in the morning when it's all nice and dark. So within this, you can actually configure this to say, when does daytime start and when does nighttime start? And you can configure two brightnesses, a night brightness and a daytime brightness. And this is currently the daytime brightness. It's nice and bright. And then when it gets to say whatever you define to be the nighttime, it'll automatically dim down to a low level. And then in the morning, when the daytime starts, it'll brighten back up again. So that's what these values refer to here. This is basically in the EEPROM, which is EEPROM is basically sort of permanent memory storage within the Arduino. So you can store values in the Arduino that'll stay there even when it's turned off. So things like configuration, we can store in the EEPROM. And that's basically the addresses of the EEPROM locations. Here we've got the MP3 player defined with the pins we defined earlier, the reset pin, clock pin, data pin, and so on. We're instantiating or declaring some instances of things like the real-time clock, the I2 extender. So this is all just initialization here. This is an interesting one, the keypad layout. That took quite a lot of working out. So, yeah, you don't want to really sort of faff around with that too much. That's a bit of a nightmare. That just works, hopefully, so don't touch it. So we set up the keypad and we create a few variables and things here. Nothing too exciting. This is an interesting one here. We've got this enum or enum, depending how you pronounce it, called states. And we'll come to this in a little bit later. Here we've got the sounds, so you can see we've got some constant declarations for the sounds we use. So these just basically number the sounds from 0 to 10, and these are familiar to you if you've seen the table that we looked at on the website. We have a setup routine. Setup basically gets called the first time the Arduino fires up. So we start up the I2C interface. That's, if you remember, that's the GPIO extender that we talked to over I2C. All that does really is gives us 2 extra IO ports where we can control the red, green flashing LED on the front. That sets that up. We start up the LCD device and we're setting the backlight pin for the LCD to an output, just general kind of stuff here, nothing really exciting. So we do some initialization here in setup. And then you can see we've got a function here, set LCD brightness. We'll probably come back to that. But the thing we want to look at is loop. Now on an Arduino, loop is like, it is the main loop. So when an Arduino runs, it just runs the code in the loop over and over and over again really fast. So that's basically where we process everything. So what we've got, we mentioned this state enumeration earlier up here somewhere. So states, the way this works is basically a finite state machine. That sounds really clever. Finite states machine, you know, sounds really exotic. You can go down a pub and really impress your mates by saying, yeah, I've been working on a finite state machine today. Yeah, nothing special really. It's really not that special. A finite state machine, if you're not familiar with one, basically the 3 words, finite just means limited number of things. State, well, state describes the state of something. So like with something like this, the state can be off. The state can be, when we turn it on, the state can be initializing. And you can see here, it's sort of doing initializing things. Here, the state has just gone into waiting for password. So the state of this is what is it doing at the time? So if you think about finite state, it just means that the code for this is a piece of code that has a limited number of different states it can be in. Why they call it a machine, I don't know. I think that's more of a mathematical term. So in software, a finite state machine is more like a finite state algorithm or finite state code. But it's called an FSM or a finite state machine. They can get really complicated, believe me. They can get really sort of advanced. So we're using a really simple one here. And the states that the CSGO prop can be in is initializing, which when it's starting up and it's wishing you to have a nice day in all your antics. Entering a password. The state can be counting down to disaster or being defused. The state can be exploding. The state can be configuring, which is when we're in this, you were using the Windows Desktop Client configurator to set things like the time and the LCD brightness. And the state can be, it's a clock. So if we go back to the loop, basically what we do in the loop, every time we go through the loop, we look to see what state the finite state machine is in. In other words, what state is the CSGO prop in? And depending on what state it's in, we then go off and do what that state requires. And that's basically it. That's a finite state machine. And it's really basic form. You know, so they get more complex, but we're using a really simple one. So you can see here the very first statement, if the state is configuring, then we return. And when we're configuring it, the actual device doesn't do anything. It's all USB and communications and stuff. So if we were configuring, just return and do nothing. So every time we hit the loop, it just loops again and again and does nothing. If the state is initializing, then we do the initialization sequence. So we can have a look at that. Now, one of the reasons I like using Visual Studio for coding Arduino stuff is you get a lot more kind of advanced programming features. And one of them is that you can, like, if you want to go and see what this bit of code does, is you can hold Control and then click on it, and it will take you to that function. So if we look at do initialization sequence, you can see this is now going to step through these lines of code one at a time. And the first thing it's going to do is do LCD print left justified, then in quotes Bang-O-Matic 5000, which is obviously the make and model of the prop. And all that does, this function here, is if I click on that, we've got a little helper function that I've written that you can basically call this, pass it a string, and it'll basically left justified print it onto the LCD panel. Don't need to go into how all that works, just know that it does. So if I've just clicked the back button on the mouse there to go back to this point, so we print something on the screen and then we delay 2000, that just creates a 2-second delay. So it prints Bang-O-Matic 5000 to the LCD, waits 2 seconds, and then it prints have nice day, because we should always be polite in anything that we're blowing up, you know. We then wait another 2 seconds, and then we call play sound async. Now, if I click on play sound async, you can see it says C4 initiate sound. You can see here all we do is we call the MP3 player, and we say async play voice and file number. And the file number is basically this constant here. So if I hover over that, you can see it says C4 initiate sound has a value of 6. So that would be 0006.AD4, the sound file. And that's it. So if you want to play a sound, you just tell it what sound to play and it will play that. Then we have a function here, red LED true. All that does is turns the red LED on the front. We wait 100 milliseconds, a tenth of a second, and then we do red LED false. So we blink the red LED for a tenth of a second. We wait another tenth of a second, and then we blink the green LED. Wait a tenth of a second, turn it off. So we get that really quick sort of little flash of activity on the LED by doing that. We then print left justified the password characters, and we set the password string. And then the state of the machine, once we've done the initialization, you see, we're in the initialization state, and we go through all the things in initialization, and then we change the state. The state changes from initialization to waiting for a password. So the state becomes enter password. We reset something here, don't worry about that. And the state becomes enter password. Now what happens then is the flow of control returns out of this function back to the loop where it was. So if we go back up to the loop, let me just find that here, just to be lazy. There it is, loop. And we did the initialization sequence, and now the state changes into password. Now, the next thing we do is here we're basically getting keys from the keypad. So before we do anything else, we're then looking to see, have any keys been pressed? And here's a bit of code that handles checking what keys have been pressed. So if there are keys that have been pressed, we see what's happened to the key. We see whether the state has changed for that key. And then we check the state itself. And these are all this is all code that's embedded in the keypad library that we imported. So we don't have to write all that. So if a key is pressed, then we play the key pressed sound. So when you press a key on the device and you hear the sounds, we're playing sounds. We're playing the key click sounds from the game. So we play a sound. If the state is countdown, in other words, the thing's counting down to explode. So if we detect a key press during that time, then if we're counting down, we then go off, defuse the bomb, and we return. If the state is a clock, then we set the state to be initializing. Otherwise, we basically assume that the key press is someone typing in a password. So we add that to the password checking code. You can see here we've got a special state where if a key is held, in other words, when we want to turn this into a USB device, let me see if I can just show you what I mean. If I turn this on, we'll let it boot up. So what I'll do, if I press and hold a key for 3 seconds, I think you can see that there. You see we have USB mode enabled now. The keypad and the code for it can actually detect key holds, and that's what that's just done. So that's what you can see here. So if the key state is hold and the character is the asterisk, then we go into USB mode. So that's how we go into that configuration. We'll talk a little bit about that in a little while. It's a bit more state handling. So if the state is countdown, we do the countdown. And if it's exploding, we do exploding. And then at the end, we've got some clock code that's just basically works out how long has sort of passed between each time we've been through the loop. Bear in mind, the loop can execute really fast. This is a way of us checking, times and setting times and things. So we'll just have a quick look at, well, here we go, look, defusing the bomb. So we've got defusing, which was, where was that? There we go. So if someone presses a key during the countdown, so if the state is counting down or countdown, and the key is pressed, any key, then we defuse the bomb. And this is the defuse sequence. And again, you can modify these as you want. You can have a play around with these. So when we defuse the bomb, we wait half a second. we print on the screen defusing, we wait half a second, and then we play sound defusing USA sound. And then we print defusing with 2 dots, wait a second, and then we add another dot. So that basically every second we add another dot onto the display, and it just makes it look like the dots are growing. But we do it by writing the whole text string to the screen, not just the extra dot. Then we play the diffused sound, we wait a second and a half, and then we update the screen to say BOMOS v2.1 safe mode. And we play the diffused sound. We wait just under 3 seconds, and then we say counter-terrorists win. And then the state goes back to being a clock, and it just turns back into being a bedside clock again. Okay, so that pretty much covers the source code without actually running through each and every single line in the code. As always, if you've got any questions about the source code, then you can always comment below or leave a comment on the blog site or head over to the Patreon, and we can chat about things over there. So the next thing to talk about is the CSGO C4 configurator. Okay, so I'm back over on the blog site in a moment, and you can see we've got a section here about the CSGO C4 configurator. Now, as we've said, this thing doubles up as a bedside clock. So you can see you've got your bedside clock, and being a clock, you're going to want to be able to set the time on it. Not only that, as we said, the LCD has a brightness you can set, and you probably want a different brightness during the day as you do in the evening. So if you scroll down here, you can see we've got this little application called the CSGO C4 configurator. Now, in the zip file that you can download, if you dig around in there, you'll find there's a bin folder with a thing called CSGO C4 client.exe, and you double click that, and you plug your CSGO prop into the USB, using a USB port on the back, and basically follow the instructions on the web page. And this lets you connect to the CSGO prop via USB. You can see you've got USB mode enabled on the front panel, and it'll then basically load all the settings from the CSGO prop into this little application. And from there, you can basically set it all. You can set the current time. So set the time and then click the save button, and that will upload the settings back to the CSGO prop. And as we said before, it'll save that into EEPROM, electrically erasable, programmable, read-only memory. Yeah, just persistent memory is all you need to know with that, really. So yeah, you can set what time the daytime begins. So here we said daytime begins at 8:30 in the morning, and the daytime brightness is 50. And if you click on the test button, that will send that brightness straight to the device, and you can see how bright or dim that is. And then nighttime, here we said nighttime begins at 2200, 10 o'clock at night, and you can set the nighttime brightness and click on save. That's pretty much it. That is pretty much the end of all 4 parts of this series. And if you've watched this far, congratulations. Congratulations for making it this far. I hope you've had fun following along. I hope you've built your own one, and I hope that this video about the software is going to be the final piece you need to actually make it work and function and all that kind of stuff. Big thank you to everyone that's subscribed to my channel so far, everyone that's given me a thumbs up on my videos. Really appreciate all your comments as well. I read all the comments and I reply to as many as I can. And as always, if you've got any questions about anything here, leave a comment, head over to the blog side, comment there, join us on Patreon, and we can sort of discuss things there. As I say, I hope you've enjoyed this as much as I have, and until next time, thanks for watching.